So I'll talk real quick about object serialization with HDF5. And some of what I share may really be scary. I often encounter developers that have C++ codes or even C codes that have a lot of data structures in them, such as these three here. Notice that there's some data members that are just, ints and floats, and then there's some data members that are pointers. So in this case, I have a linked list at the top, a tree in the middle, and then a list of trees at the bottom. So it might look visually like this. There's a linked list at the top. Over there in the left corner is a tree, and then here's a list of trees with a doubly linked list. And the question is, how do I write this to HDF5? The answer for a lot of developers that are completely naive to the HDF5 interface is we'll define memory types for all the non-pointer members of those three different types. And then we will recursively traverse those structures. And every time you cross a pointer, you create a group in the HDF5 file. And then every node, you create a one datum data set, which is all the members of that particular node. And that code to do that is just dirt simple. It's really easy to write. Unfortunately, it is horrendous in terms of I/O. So I had a user at Livermore Labs that had basically an application with 20 megabytes of this kind of data, and the file he produced was 1.5 gigabytes because of all of the metadata that was in the file. So the problem is, how do you do this better? So the coding's really simple to do, though, and it's really easy for people to fall into this trap, I think, when they're going to write out complex data structures to HDF5. So the optimized approach. I create memory types for where the pointers are basically opaque 8-byte types, and I label them. I give each one a different name. And for the file type, I actually replace the pointers with offset, size t's, offsets basically. And then I have a conversion routine that converts from the opaque types to the off t's basically. And then I allocate 3 arrays, one for each class, one for each type. Traverse the structures once to get an idea of how big those arrays need to be, and then I traverse the structures a second time, and each time I basically, as I encounter a particular a particular type, the first time I encounter it, that's its index in the actual data set that it's going out to. I write that one type, that one instance of it, and basically write to all the various data sets as I traverse out. In the file, what you get is still the linked types, but it's the offsets within the data sets that are being actually stored to the file. One final, and that works great. Yeah, it's really high performant, works awesome, but it's highly complicated to use HDF5 to do this. And so I would not expect anybody that's naive, that basically is a science code developer, to ever get to this point in writing code to use HDF5 this way. This is a problem that needs to be solved. And just another real quick thing, I see I have 2 minutes. So I have a lot of our codes, I've talked about restart files yesterday. Codes open an HDF5 file, they dump all their state to it, and then close the file. So can you use that as a form of object serialization? And yes, you can, because John and Elena added file image capability HDF5. I think this is back in 2012 at this point now. What the application does is it opens a file in memory. It writes its one domain. A domain in this example is one of those colored spots. It's a piece of the mesh. Writes all the state for that domain out into a file image. MPI sends that message to a different processor. That processor opens that file and reads it in, and that's how it migrates an entire piece of the mesh to a different processor. That's just another form of serialization. And I think that's all I wanted to say about that. You can see some example. I'm trying to basically develop a set of examples. You can see some examples if you wanted to at that address on GitHub. It's not great code. It's all just, research code. Research code.